They're anxiously waiting to see if the New Horizons spacecraft, after a 3 billion-mile journey, successfully snapped pictures of Pluto during its close flyby this morning.
Pluto, known as a dwarf planet, is a small and distant world located at the edge of our solar system, billions of miles away from the major planets. Despite its size, Pluto has remained one of the most fascinating objects in space, leading scientists to conduct years of research into its mysteries. Now, using the powerful James Webb Space Telescope, researchers have uncovered an astonishing discovery never seen before in decades of studying Pluto, one so unexpected that it challenges what scientists believed was possible on this frozen world. Join us in this video as we uncover this discovery. James Webb reveals Pluto's hidden secret. The James Webb Space Telescope was built to explore the deepest mysteries of the universe. Its primary mission was to study the oldest galaxies ever formed, examine distant exoplanets, and capture the earliest light left behind from the birth of the cosmos. Pointing such an advanced telescope toward a small, icy dwarf planet in our own solar system almost seemed like an unexpected use of its incredible capabilities. But scientists knew Webb possessed something no telescope that had ever observed Pluto could offer. It carried extraordinarily sensitive infrared instruments capable of detecting wavelengths of light that had never before been measured on Pluto. Using its powerful mid-infrared instrument, known as MIRI, Webb accomplished something truly remarkable. For the first time in history, astronomers were able to separate the heat signatures coming from Pluto and its largest moon, Charon, allowing each world to be studied on its own. Every previous infrared observation, including data collected by missions dating back to 1997, had merged the two bodies into a single blurred signal, making it impossible to distinguish one from the other. Webb's exceptional resolution and advanced optics were finally powerful enough to tell them apart. The telescope's first major discovery confirmed an idea that had existed only as a scientific prediction for nearly a decade. In 2017, a planetary scientist proposed that Pluto's thin atmosphere contained a layer of haze so effective at radiating heat into space that it was actually cooling the entire dwarf planet. At the time, there was simply no technology capable of testing that bold hypothesis. For years, the theory remained unproven, existing only in computer models and scientific papers. Then James Webb turned its infrared instruments directly toward Pluto. Almost immediately, the faint infrared glow produced by that predicted haze layer appeared exactly where the models had suggested it would be. The scientist who first proposed the idea later admitted that it is incredibly rare in planetary science for a theoretical prediction to be confirmed with such precision and in such remarkable agreement with observations. Even on its own, that was a groundbreaking discovery. A thin, hazy atmosphere, somewhat similar to the smog found high above Earth's skies, was quietly controlling the temperature of an entire world billions of kilometers away. But the haze turned out to be doing something even more extraordinary than simply cooling Pluto. Webb's observations revealed that this high-altitude layer is actively carrying methane and other complex organic molecules away from Pluto's fragile atmosphere. And this is where the discovery begins to sound almost like science fiction. Instead of drifting endlessly into the emptiness of space, some of those escaping molecules are being pulled across the gap separating Pluto from its largest moon, Charon. There, they eventually settle onto the moon's frozen surface, slowly coating it over time. Scientists have begun describing this astonishing process as an atmosphere spilling from one world onto another, a form of planetary transfer unlike anything else ever observed in our solar system. It is a phenomenon so unusual that, based on everything we currently know, Pluto and Charon may be the only pair of worlds where one body's atmosphere is continuously feeding material directly onto the surface of another. Following James Webb's groundbreaking discoveries about Pluto, what even more shocking secrets could this distant world still be hiding? Keep watching to find out. The discovery that changed what we know about Pluto. Pluto is doing something no other world in the solar system is known to do. It is slowly transferring part of its atmosphere onto its largest moon, Charon. Molecules are drifting across nearly 12,000 miles of empty space in a slow but continuous process that has likely been taking place for millions of years, completely unnoticed until the James Webb Space Telescope finally revealed it. But Pluto was not the only world keeping secrets. Charon had mysteries of its own waiting to be uncovered. Using Webb's incredibly sensitive infrared spectrograph, scientists detected carbon dioxide and hydrogen peroxide frozen across the moon's icy surface. These chemical fingerprints had remained invisible to every telescope and spacecraft that had ever observed Charon since its discovery back in 1978. The discovery could provide some of the strongest clues yet about how Charon was actually formed. For decades, scientists have debated whether the moon was created after a gigantic collision with Pluto or through another violent event that happened billions of years ago. These newly discovered chemical signatures may finally provide the evidence needed to settle one of the longest-running debates about Charon's mysterious origin. What makes the discovery even more remarkable is that Charon had been studied for nearly 50 years. It has been observed by powerful telescopes, photographed by spacecraft, and analyzed countless times by scientists around the world. Yet despite all those observations, it still managed to hide two important chemical compounds from every instrument that came before James Webb. That alone is a powerful reminder of how much we still do not know, even about worlds we have already explored up close. The scientists behind the research say Charon's chemical inventory is now more complete than it has ever been before. Even so, they also acknowledge that many questions remain unanswered. There are still regions of the infrared spectrum that Webb has not fully explored, meaning future observations could reveal even more unexpected discoveries hidden beneath the moon's frozen surface. But impressive as those discoveries were, they were only the beginning. What came next was far more puzzling, because this is where the evidence stopped fitting into anything scientists expected. Earlier this year, researchers carefully analyzing Webb's spectral data noticed something unusual buried within the light reflected from Pluto's surface. They found a very narrow dip in the spectrum at a wavelength of just over 5 microns, a part of the infrared spectrum that had barely been explored before the James Webb Space Telescope became operational. That tiny dip revealed that something on Pluto's surface was absorbing that exact wavelength of light. Normally, this is one of the easiest parts of the investigation. Every chemical molecule interacts with light in its own unique way, producing a distinct pattern that acts like a fingerprint. By comparing those fingerprints with laboratory measurements, scientists can usually identify the chemical responsible without much difficulty. But this time, the fingerprint belonged to nothing anyone recognized. The research team searched through extensive spectral libraries containing the signatures of known frozen compounds, including ethane, ethylene, acetylene, propane, benzene, and hydrogen cyanide, molecules that have already been confirmed to exist somewhere within Pluto's environment. One by one, every possible match was tested, yet none of them lined up with the signal Webb had detected. The mysterious absorption feature simply did not belong to any chemical ever cataloged in the known chemistry of our solar system. Then the mystery deepened even further. What unexpected discovery pushed scientists to investigate Pluto further using the powerful instruments of the James Webb Space Telescope? Stay tuned to find out. How scientists finally uncovered Pluto's secrets. In July 2015, after an incredible journey lasting 9.5 years and covering billions of miles through the cold emptiness of space, NASA's New Horizons spacecraft finally arrived at Pluto. Racing through the darkness at more than 30,000 miles per hour, the spacecraft reached a moment that scientists had spent decades preparing for. But New Horizons had only one opportunity to unlock Pluto's secrets. It was never designed to slow down and enter orbit around the dwarf planet, and there would be no second attempt for another close encounter. The spacecraft had only a brief window of a few precious minutes to collect as much information as possible before continuing its path beyond Pluto and deeper into the mysterious Kuiper Belt, leaving the distant world behind forever. The information New Horizons sent back completely transformed humanity's understanding of Pluto. Scientists expected to find a frozen, quiet, and inactive object drifting at the edge of the solar system. Instead, they discovered a world filled with unexpected activity, complexity, and geological surprises. Spread across Pluto's surface was a massive, bright, heart-shaped region stretching across hundreds of miles, a feature later named the Tombaugh Regio, in honor of Pluto's discoverer, Clyde Tombaugh. Unlike the ancient, heavily cratered terrain surrounding it, this region appeared remarkably smooth and surprisingly young, suggesting that Pluto's surface was not frozen in time, but had been constantly changing and reshaping itself. Rising above the surface were enormous mountains made from solid water ice, some reaching more than 10,000 feet high. Under Pluto's extreme temperatures, this frozen water was not soft like the ice found on Earth. Instead, it became incredibly hard and rigid, behaving more like solid rock than ordinary ice. Scientists also discovered vast regions covered in nitrogen ice that appeared to be slowly moving through giant circulation patterns known as convection cells. These patterns suggested that heat and movement were still occurring beneath Pluto's outer crust, challenging the long-held belief that such a distant world would be completely frozen, silent, and geologically dead. The discoveries became even more surprising when New Horizons revealed Pluto's complex atmosphere. High above the surface, scientists detected layers of blue haze stretching hundreds of miles into space. The haze became especially visible when sunlight passed through Pluto's atmosphere from behind, creating a glowing outline around the distant world. This discovery revealed that Pluto was surrounded by a much more active and complicated environment than anyone had expected. It was not simply a forgotten piece of frozen material abandoned at the edge of the solar system. Instead, Pluto appeared to be a living world in its own way, a place that was still changing, still evolving, and still undergoing processes that scientists were only beginning to understand. However, despite the groundbreaking discoveries, New Horizons had only one chance to study Pluto. The spacecraft collected the data it could during that brief flyby before continuing its journey farther into the outer solar system. Every detail it failed to capture during those few moments would remain a mystery for years to come. Scientists carefully analyzed the information, debated what the discoveries meant, and created detailed models to explain Pluto's unusual behavior. But Pluto's mysteries may not end here. Could this distant world still be hiding more shocking discoveries waiting to be uncovered? Stay tuned to find out. The discovery. Waiting after New Horizons. But there was one major limitation. They had no spacecraft nearby to return and investigate further. What scientists needed was not simply another photograph of Pluto's surface. They needed a completely different way to study the dwarf planet, one that could reveal its chemistry, atmosphere, and hidden processes from millions of miles away without requiring another spacecraft to spend nearly a decade traveling there. Eventually, the James Webb Space Telescope provided exactly the tool researchers had been waiting for. The reason Webb is so different from a spacecraft like New Horizons comes down to how it studies distant worlds. New Horizons had to physically travel close to Pluto and capture images while moving at incredible speed during its short encounter. Webb, however, does not need to travel anywhere. Instead of only taking pictures, it studies the light coming from distant objects. It separates that light into individual wavelengths, allowing scientists to uncover the unique chemical fingerprints hidden within the signals. By examining the faint sunlight reflected from Pluto billions of miles away, Webb can determine which molecules exist on the surface, analyze the composition of Pluto's atmosphere, measure temperatures across different regions, and observe how the dwarf planet's environment changes over time, all without ever physically reaching Pluto. The challenge of achieving this was far greater than it may seem. From Webb's location, Pluto and Charon appear extremely close together in the sky. Their signals overlap so much that separating their individual thermal signatures was nearly impossible with previous generations of telescopes. Before Webb was launched, scientists had repeatedly searched for evidence of Pluto's atmospheric haze, but their efforts came up empty again and again. The reason was not because the haze was absent. The problem was that older instruments could not separate Pluto's own heat from the additional infrared signal coming from Charon, its large neighboring moon. The two worlds appeared blended together, making it extremely difficult for researchers to determine which signals belonged to Pluto and which came from Charon. Among all the discoveries revealed on Pluto, one feature stood out: the mysterious blue haze surrounding the dwarf planet. But what could this strange phenomenon reveal about Pluto's hidden secrets? Keep watching to find out. The hidden secret behind Pluto's blue haze. The first major discovery focused on the same mysterious blue haze that New Horizons captured for the first time during its historic 2015 flyby. Scientists already knew that Pluto's extremely thin atmosphere was surrounded by a delicate layer of hydrocarbon particles, creating a faint blue glow around the distant dwarf planet. However, one major question remained unanswered. What role was this strange haze actually playing in controlling Pluto's environment beneath it? In 2017, planetary scientist Shi Jiang from the University of California, Santa Cruz, introduced an idea that seemed almost impossible at the time. Scientists had already observed a similar type of atmospheric haze on Saturn's moon Titan, where the haze works like a protective layer that traps heat and helps warm the surface below. But Jiang suggested that Pluto's haze might behave in the exact opposite way. Instead of acting as a shield that keeps heat trapped, Pluto's haze could actually be helping the dwarf planet lose heat. Jiang proposed that the tiny haze particles absorb energy from sunlight during the day, store that energy temporarily, and then release it back into space in the form of infrared radiation. Because Pluto's atmosphere is incredibly thin and unable to hold large amounts of heat, this process would allow energy to escape much faster than it could accumulate. Put simply, Pluto's haze was not behaving like a thick blanket wrapped around the planet to keep it warm. Instead, it was acting more like a natural cooling system, a giant radiator floating in Pluto's atmosphere, constantly sending heat away and lowering the temperature of a world that already exists in one of the coldest environments in the solar system. At the time, this theory was considered unusual and unexpected by many researchers. There was also a major obstacle standing in the way of proving it. Scientists could create computer models and make predictions about how Pluto's atmosphere might behave, but they had no instrument powerful enough to directly measure the faint heat escaping from Pluto and confirm whether the haze was truly responsible for cooling the planet. That changed when the James Webb Space Telescope's mid-infrared instrument, known as MIRI, became fully operational. Webb possessed the sensitivity needed to detect Pluto's extremely weak thermal signal and, more importantly, separate that signal from the heat coming from Charon, Pluto's largest moon. Earlier telescopes had struggled with this because Pluto and Charon appeared too close together, causing their infrared signals to blend into one unclear measurement. Using Webb's advanced infrared capabilities, a team of researchers led by astronomer Tanguy Bertrand from the Paris Observatory closely examined Pluto's atmosphere. Their findings, published in the journal Nature Astronomy in June 2025, confirmed almost exactly what Jiang had predicted 8 years earlier. The study revealed that Pluto's upper atmosphere is genuinely being cooled by the same haze particles floating within it. Even more surprising, researchers discovered that Pluto's atmosphere was approximately 30 degrees Fahrenheit colder than previous scientific models had predicted. This meant that the tiny particles suspended high above Pluto's surface were having a much greater impact on the dwarf planet's climate than scientists had ever realized. Researchers now describe this as a completely new type of climate system, one unlike any other atmosphere scientists have studied anywhere else in the solar system. Pluto is not cold only because it is located billions of miles away from the Sun. Instead, the dwarf planet appears to be actively contributing to its own cooling through a natural refrigeration process created by its own atmospheric haze. Scientists are still working to understand the full consequences of this discovery and how far its influence extends. This discovery has raised new questions about whether similar haze layers could also be shaping the climates of other distant worlds, including Neptune's moon Triton, which also contains a complex, hazy atmosphere. To understand the significance of this discovery, let's take a step back and explore how Pluto came into existence and became the mysterious world we know today. The discovery and mystery of Pluto. In 1930, a 24-year-old assistant named Clyde Tombaugh, working at the Lowell Observatory just outside Flagstaff, Arizona, was given one of the most challenging and repetitive tasks in astronomy. His mission was simple in theory, but extremely demanding in practice. Photograph the same region of the night sky on different nights, then carefully compare the images to search for any object that had shifted position. Using a technique called the blink comparator, Tombaugh repeatedly switched between the photographic plates, looking for a tiny point of light that moved, while the countless background stars remained perfectly still. Night after night, the search produced nothing. The endless comparisons revealed no new object hiding among the stars. But then, in February of that year, everything changed. While examining a set of photographic plates, Tombaugh noticed something unusual, a tiny speck of light that had moved slightly from one image to another. Against the massive field of motionless stars, that small moving dot revealed the existence of a new world. That object would later be named Pluto, becoming one of the greatest astronomical discoveries of the 20th century. For nearly a century after its discovery, Pluto held the prestigious title of the 9th planet in our solar system. Yet, despite its importance, it remained one of the most mysterious worlds ever known. Its extreme distance from Earth and its incredibly small size made it almost impossible for scientists to study directly. Even the most advanced telescopes could only capture Pluto as a faint, blurry point of light, leaving astronomers to make predictions and educated guesses about what its surface and environment were truly like. Then, in 2006, Pluto's long-established identity changed forever. The International Astronomical Union gathered and held a historic vote that officially reclassified Pluto as a dwarf planet. The decision removed Pluto from the list of recognized planets, taking away the title that had made it famous around the world for generations. This made Pluto a unique case in the history of astronomy. It became the only known world to be discovered, celebrated as a full planet, and later officially removed from the very category that had defined its place in the solar system. For many years, it seemed like Pluto's story had reached its conclusion. It was viewed as a small, frozen, distant object at the edge of our planetary neighborhood, a world that was interesting, but perhaps not important enough to receive much attention. But that assumption began to collapse once scientists finally started receiving real information from Pluto itself. To understand why Pluto's later discoveries were so surprising, it is important to recognize how little we truly knew about this distant world before any spacecraft ever traveled there. For most of the 20th century, even the largest and most powerful telescopes on Earth could only observe Pluto as a tiny, unclear spot of light moving slowly across the sky. Scientists could accurately calculate its orbit around the Sun because they could track its movement over many years. However, some of the most basic questions about Pluto remained unanswered for decades. Researchers did not know its exact size, what materials covered its surface, how complex its environment might be, or whether it even possessed an atmosphere. Early estimates of Pluto's size were also far too large because scientists believed it needed to be much bigger to explain unusual gravitational effects they thought were influencing the orbits of Neptune and Uranus. However, as technology improved and more accurate measurements became available, scientists discovered that those strange orbital changes were not caused by Pluto at all. Instead, they were the result of mistakes and limitations in earlier calculations. The truth was that Pluto was much smaller, much more distant, and far more mysterious than anyone had originally imagined. Although Pluto is a small and distant world, could it hold a deeper significance and connection with the other members of our solar system? Keep watching to find out. The gravitational mystery of Pluto and Neptune. Although Pluto's orbit may appear to cross Neptune's when viewed from above or below the solar system, the reality is very different. The two worlds never actually come close enough to collide. When Pluto reaches the point in its orbit where it is closest to the Sun and seems to overlap with Neptune's path from that perspective, Pluto is not moving through the same region of space. Instead, it is positioned far above Neptune's orbital plane. In reality, Pluto's orbit passes about 8 astronomical units, AU, north of Neptune's orbit, creating a huge separation that prevents any direct encounter between the two distant worlds. However, this distance alone is not enough to completely explain why Pluto remains safe. Over millions of years, the gravitational forces from other planets, especially Neptune, can slowly influence and reshape the paths of objects in the solar system. These tiny gravitational changes, known as orbital perturbations, could gradually alter Pluto's orbit over extremely long periods of time. Without another protective mechanism, these changes could eventually create the possibility of a dangerous close approach between Pluto and Neptune. But Pluto has an additional and much more powerful protection: a special gravitational relationship with Neptune known as a 2 to 3 orbital resonance. This means that every time Pluto completes 2 full trips around the Sun, Neptune completes 3. Their movements are locked into a precise pattern that prevents them from ever reaching the same position at the same time. This resonance is measured from a rotating frame of reference that follows the slow movement of Pluto's closest point to the Sun, known as its perihelion. Over time, Pluto's perihelion slowly shifts at a rate of approximately 0.97 times 10 to the -4 degrees every year. The complete pattern of this orbital relationship repeats approximately every 495 years. Pluto is not the only object protected by this type of gravitational arrangement. Many other objects in the Kuiper belt also share the same 2 to 3 resonance with Neptune and are classified as Plutinos. During the first time Pluto reaches perihelion within one of these 495-year cycles, like it did in 1989, Neptune is positioned about 57 degrees ahead of Pluto along its own orbit. By the time Pluto returns to perihelion during the second half of the cycle, Neptune has already completed another 1.5 orbits around the Sun. At that point, Neptune is positioned about 123 degrees behind Pluto instead. This carefully timed orbital dance is the reason Pluto and Neptune never come dangerously close to one another. Their closest possible approach is still more than 17 astronomical units apart, which is actually farther than Pluto's closest distance to Uranus, which is around 11 astronomical units. Even more interestingly, the moment when Pluto and Neptune reach their minimum separation does not happen when Pluto is closest to the Sun. Instead, their closest distance occurs when Pluto is near the farthest point of its orbit, called aphelion. The relationship between Pluto and Neptune is one of the most stable gravitational arrangements known in the solar system. This resonance has remained intact for millions of years, constantly preventing their orbital paths from shifting into positions where they could collide. Even if Pluto's orbit were not tilted compared to Neptune's, this powerful orbital pattern would still keep both worlds safely separated. However, Pluto's orbit is not perfectly synchronized with Neptune's. Its orbital period is slightly different from exactly 3/2 of Neptune's orbital period, causing the timing between the two worlds to slowly shift over long periods. Despite its small size and distant location, what significance does Pluto truly hold? And why does this mysterious world remain important to science? Stay tuned to find out. The legacy of Pluto's discovery. After Pluto received its official name, a planetary symbol was created by combining the first two letters of the word Pluto, PL. This design served as a simple monogram representing the newly named world and became the original symbol associated with Pluto. However, as astronomy developed, this symbol gradually became less common among scientists and is now rarely used in modern astronomical writing. Despite this decline in scientific use, the symbol remains more popular in astrology, where Pluto continues to have a strong presence. Another symbol connected with Pluto, and one that is occasionally used in astronomical and astrological contexts, features an orb placed above Pluto's traditional bident symbol. Some interpretations suggest that the orb represents Pluto's mythical invisibility cap, a reference to the legendary helmet said to make its wearer unseen. This symbol became widely recognized during the early 1930s, shortly after Pluto's discovery, and it continues to be associated with the dwarf planet today. The name Pluto quickly spread beyond scientific circles and became part of global popular culture. In 1930, shortly after the discovery of Pluto was announced, Walt Disney appears to have drawn inspiration from the newly discovered celestial object when creating Mickey Mouse's loyal dog companion, Pluto. The character made its first appearance not long after the discovery, making the name familiar to millions of people around the world. However, Disney animator Ben Sharpstein later explained that he could not confirm the exact reason why the name Pluto was selected for the famous cartoon dog. The influence of Pluto's name also extended into the field of chemistry. In 1941, scientist Glenn T. Seaborg named the newly created chemical element plutonium after Pluto. This choice followed an established tradition of naming newly discovered elements after planets. Uranium had previously received its name from Uranus, and Neptunium was named after Neptune. Following this pattern, plutonium was named after Pluto, continuing the connection between discoveries in space and discoveries in chemistry. Around the world, different cultures and languages adapted the name Pluto in their own unique ways. Could these discoveries about Pluto be the end of the solar planets? Share your thoughts in the comments section below. Thank you for staying with us as we explored more discoveries about Pluto through James Webb. But could there be even more to this discoveries than we realize? Don't forget to like and subscribe. Click the next video on your screen to explore more stories. See you there.